Hi, I'm James Zerkert, and I'm the author of Flow Architectures, the Future of Streaming and Event-Driven Integration. There's some links here that you can use to get a copy for yourself if you wish. What I want to focus on today is one of the things I did in the book, and I asked the question on LinkedIn one day about whether people wanted to understand more about what I did here, and that is applying promise theory to Wardley mapping to improve the capability and the outcome of your Wardley mapping session. So hopefully go through this fairly quickly for you. If you don't understand Wardley mapping very well, I'll include some links in the description below about where you can find more. And there's also a link to Simon Wardley's website around mapping as well later in this presentation to support that. And then also for Promise Theory, I'll provide a link to Mark Burgess's book and work on promise theory. Let's start with Wardley mapping, just to understand what it is at a high level. It's a way to understand a market, a problem space, any sort of metaphorical kind of landscape and climate thing you're trying to understand so that you can make smarter decisions, better strategic decisions about where to invest time, money, energy related to that problem or market or whatever it may be. So this is a Wordly map in its final form and one of kind of its more complicated and sophisticated appearances. We're not going to get to this level today, but to just give you an idea, from a Wordly map you can understand a lot about how you can assign people with different skill sets to the work that has to be done, where you can acquire technologies that may be readily available, that can be outsourced easily, where you might want to purchase an off-the-shelf product or build your own custom thing and try to build some innovation and capability into what you're doing. And it's really interesting because Simon's done a ton of research and work in this space. And this is one of the most powerful strategic planning tools I have ever come across, and I use it all the time. So what does a sort of basic Wordley map task look like? Well, we're going to start with understanding who are the users that we're supporting, and we want to identify at least one need related to the space that we're talking about. Keeping the scope somewhat limited is really helpful. So what we're going to focus on here is what I call flow integration, right? The ability to integrate event streams and near real-time data exchange across domain boundaries. And those domains could be companies, they could be organizations within a company, business units or whatever. They could be between companies and different institutions of different sort and so on. When we go through this, we're going to end up with first a needs graph. We're going to understand sort of these are our users at the top there, and these are the different this is the need that we're identifying for them. So we're going to talk about flow integration. We're also going to then identify sort of all the components that are being used in terms of delivering this capability. And so there's sources and sinks, the things that deliver and the things that consume, and we'll talk more about that in some more detail later. And then there's all the different other components that you use to take events that are coming from sources and deliver them out to these other organizations, where ultimately they'll end up in some form of sink, being either stored data or handed off to a different flow of some sort, or potentially processed in some way that it generates a different set of events. And then ultimately, and we'll kind of land at the end with a map of that set of user needs that we can begin to evaluate. And I'll talk a little bit about the evaluation. But first, we're going to talk specifically about how to build that needs graph and evaluate it and question it using promises. So Mark Burgess's great work on promise theory. Here's a link to his book. Highly recommend taking a look at it. Promise theory basically says, well, you've got two agents. One has something it needs from the other. That other is making a promise of some sort. So nothing can be imposed on an agent An agent basically, of its own free will, makes available a promise of some sort that it can deliver something. This is really about building trust from those that can deliver value to those that consume that value in some way, shape, or form, at least in the context we're talking about. And so we really want to talk about the promiser as the person who is promising to deliver something of value, and the promisee as a component or person who is then going to consume and use that. Now, we're going to use the top there with the arrows. We'll learn how this screen works in a second. We're going to use the top piece there in terms of the arrows and a single arrow to deliver sort of, this is the body of the promise. This is the description of the promise that's being delivered. But in the notation below, this is really what's happening, right? And it's important to understand that if you're going to go deeper into promise theory, that for every promise that's made, the promisee has to then make a promise that it will accept that promise and it will use that promise in some way that is appropriate for the promise that's being made. And so we're going to focus again. We're going to just use the single arrow method. But if we were really going to do this in depth from a promise theory perspective, there'd be a lot more notation on the graphs than I ended up with. Okay, so let's start just with the beginning of modeling flow to understand how we can use promises to make the graph better. I'm just going to start with a basic kind of sunny day scenario, which is we're going to start with flow integration and the two users, the producer and the consumer, and ask the question, what are the promises that are being made by the capability of flow integration to producers and consumers? And really, when you boil it down, flow integration is really about providing what seems to be publish and subscribe mechanics between two entities across the domain boundary. It's a little more sophisticated than that because you don't have to have the typical topics and anything else. You could use an HTTP connection between the producer and the consumer that's just feeding events and meet the basic needs of what's being described here and the promises that are being described here. But really, we're talking about publishing events between domains, making events available, making events deliverable between domains, and then a means to subscribe to events and consume those events. So a means to receive events and be able to take action on those events. And those are the basic promises that are being made here, pretty straightforward in the definition. And if we're going to kind of go deeper into how to build the needs graph, so we're going to start with that idea of identifying the needs, as we did in our sunny day scenario. We might identify some other needs, so we talked about sources and sinks a little bit early, and then we're going to apply and we're going to ask questions with promises. But we're going to start with identifying some promises that we think apply for every one of the edges that we create in our graph. So in here, we've added, in addition, we've talked about the fact that sources are going to provide new event data and context. They're going to generate events and information that are required in order to make the connection valuable. And then the sinks are really ultimately going to provide a way to terminate the interaction across the flow integration. There might be multiple steps in an integration, but frankly, you're really looking at once the data has been received by another organization for consumption. Generally, you're going to say, okay, what are we going to do? We're going to either generate another event flow from this event. We're going to modify the event or aggregate the event with something else and generate a new capability. We're going to store the event, and we're going to store that information and do that processing in sort of a at-rest data analytics mechanism. Or we might generate a signal immediately from the event that's been received for some purpose, which is really kind of a variation of the first thing, but is a really interesting thing when you say, hey, if it's an anomaly, raise an event, something along those lines. So just kind of starting at that point, what are the questions that I'm asking once I have identified some basic promises? So with those promises, I'm sort of asking the question, okay, if consumer, say a producer, needs flow integration to fulfill its own promises to share events with a partner, or make events available to consumers, or make events available to regulators. What does flow integration have to promise to A to meet those needs? And that's what we defined kind of up front. But I'm also going to begin to ask another question as we have more and more different connections in the graph, which is, does B really supply that promise to A directly, or is there an intermediate component, let's call it C, that that A is actually requiring a promise from, that B is using to fulfill its promise to A, right? So that the promise to A is met not directly from B, but through an intermediary that we'll call C here. And so I'll give you a really good example of that, but you can generally see this as like, in fact, there's a larger scale promise that's being made. That's actually the thing that A cares about. And the smaller scale thing that we think of as what is delivered by B ends up actually being mostly consumed by this larger scale thing. And a good example of this is when I first started doing the work, I said, well, flow connections, they need, in order to make the event valuable, in order to have interaction with the events, there's both in terms of sending the events and in terms of receiving the events, there's processing that has to happen. It has to be mapped into the standards. It has to be validated in some way. Maybe there's some access control or monetization pieces that have to happen. And then there's queues. We need to store the event until the consumer's ready to receive it, or in a way that it makes it easier for us to broadcast it out to multiple consumers, whatever it may be. But there's some form of storage that needs to happen. And like I said, you can get away without the queue, but generally there's queues involved. And so the first set of events I kind of threw out there was, well, I need a mechanism to support publish and subscribe actions and data processing and so on. That's the processor. And then I need a way to capture and hold event data for future retrieval and processing. But in fact, what that begins to already indicate is the promise that a queue makes is really not to anybody but the components that are processing, right? The different types of processors that are involved. There's no direct promise being made to the logical connection at all. Your users are not interacting directly with the queue. They're interacting with some sort of technology, some sort of processing capability that ultimately gives access to the queue, but does work with what's in the queue before it's sent across the logical connection, or once it's received from the logical connection. So I began to immediately see that, in fact, the relationship here isn't between a queue and the logical connection, but it's between the queue and the processor. And this is sort of the relationship that I ended up with, and the same promises are being delivered, but I'm really able to sort of say the queue is ultimately a holding spot for processors to be able to do something with the event. And this is true for an event directly from a source is going to go, if it goes into a queue, is ultimately going to get processed in some way for the queue. And so a processor is involved in sort of every step of this. Okay. I'm going to come back to where that ends up in the needs graph overall, but I want to just finish up in sort of what I do next, right? So I've used the promises to validate my connections. I've made changes if I discover issues with that. And then I sort of say, okay, so what's the next set of components that are needed by the components that I've evaluated so far? So for sources and sinks, they're the beginning and the end. But flow integration has the need for interfaces and protocols in an example. And I can keep then doing what are the promises between interfaces? What are the promises between protocols and flow integration? And so I identify, there's a need for standard formats for event data. There's a need for standards for initiating stream communication and maintaining that connection, flow control, all the sort of subscribe things that publish and subscribe things that have to happen. And then each of those things are going to have their own additional things that they need. So once I've evaluated and validated those connections, I'm going to look for what's the next set of needs that are needed until I get to some point where I feel I've met the scope of the problem I'm trying to deal with. I'm getting into components that really I'm not trying to evaluate. I have a much better understanding of what I'm going to do with them. The landscape is less important to the problem that I'm dealing with. But the other interesting thing I end up with is, once I have this wonderful user graph, is I also end up with a set of promises that I can continue to evaluate over time and continue to use as I look at how do I move things around on the Wardley map when I map it and so on. So I have that set of stuff that's up above me here. I will point out that there's the relationship that we evaluated that looks, very much like we talked about, that the queue is serving the processor, and the processor is the thing that's providing capability to sources and sinks and everybody else. And all of that consumes infrastructure, which is the point that I chose to kind of end the breakdown. So that this is the outcome that you get. And what I like about this is I feel very, very comfortable that everything that I've evaluated in this map needs to exist in order to meet the flow integration need, and has the right relationship, has the right promises that it's delivering to the components that need it. And of course, then I'm going to map this to a Wardley map, which we'll do another video someday about what this tells us, but it gives us a really good place to be. I will note that some of the things that are on the more to the left-hand side have changed quite a bit. I think the discovery component, for instance, has already evolved to the point where it's at least product and maybe very quickly moving towards commodity. If you look at the open source project event catalog, for example, really great opportunities there to have a very basic mechanism for discovery that goes beyond what Google and Google search can do. Of course, I still believe that a vast majority, much like with APIs, a vast majority of documentation will be discovered through search. But you can get very sophisticated in what you can discover using something like Event Catalog. The other thing is the protocol side of things. The metadata format is very quickly becoming cloud events. The CNC, the Cloud Native Computing Foundation project cloud events, which is a great specification for metadata and how to map that to a number of different wire protocols like HTTP, MQTT, things like that. And then also the payload data formats are probably moving out of the custom build space, largely because a lot of existing protocols for sending things via EDI, via a number of other exchange mechanisms, are beginning to be mapped into what is being delivered from an event. So this is just an example of how things are evolving more towards being closer to that point where that flow integration piece, that's sort of borderline product, is going to move through product and get into the commodity space. And I'd say we're still 6 or 7 years away from that being mainstream, but the movement is happening and you can see it happening. And with that, I will say thank you very much for your time, and I hope that was really helpful. I encourage you to take a look at the Flow Architectures book and the other books that I listed earlier. There's a lot of information, especially if you're really interested in event-driven integration or what event-driven integration could do for your organization over time. If you have a need to kind of get out of the batch processing game and get into closer to real-time processing with your partners, with your other business units within your organization, there's a lot of information there that can help you move in the right direction and understand what the shape of things are going to be to come, and also watch this space. I'm going to do a lot more videos on that transition as it happens, and call out a lot more things about the technology landscape as it changes and what that means towards event-driven integration. But I appreciate your time. Please, early yet, first piece of content I've created. But if this is really valuable to you, please like the video, subscribe, all the usual things that the kids do these days on YouTube. But I'd really appreciate your support and getting the word out that this content is available now. Thank you very much. Have a great day.